Race car exhaust headers are usually fabricated using a series of preformed bends and straight sections of pipe. Most often they are complex shapes arranged to clear various components whilst maintaining unrestricted flow. The life of headers can vary from car to car, but inevitably they will deteriorate to a point where they must be replaced. I was asked to fabricate a new set of headers for a 350 cubic inch Chev engine that is powering a sports sedan. The existing headers had well and truly passed their use-by date. By setting up the old system on a dummy engine, each pipe can be reproduced independently. Like most racing cars, these exhausts are accommodated in a very restricted space. It was necessary to rig up a dummy bar to replicate a chassis tube the exhaust needed to clear. I then recorded various gaps and positions of pipes as seen here. DEA Performance in Dandenong made my task considerably easier. They scanned the 50mm diameter section of the old pipes and reproduced each pipe in one continuous length. These are the 4 pipes that will form the sizable segment of the headers on the left bank. These pipes from DEA Performance will require less cutting and welding than using preformed bends and will contribute to a smoother flowing exhaust system. With the old primaries mounted on the dummy engine and assembled into the collector, it's time to start on the first pipe. I will always replace the single pipes first, then attack the centre tube. I will start with this pipe for number 7 cylinder. There is a limit to the minimum distance between bends that can be achieved, so for this pipe I will have to remove about 50mm from the straight section. I have managed to support this section of pipe by utilising a magnetic clamp, vice grips and various backers. When fabricating headers in this way, I usually work from the collector up and the head down and meet somewhere in the middle. The first section of this pipe rises up from the cylinder head to clear a chassis member, so requires a bend that is less than 90 degrees. Lacking other options, I have to resort to a hammer to shape the ends of the pipe to suit the flange. Each section of pipe is trimmed to the junction where the pipe steps up from 47mm to 50mm. After deburring and removing the scale from the flange, I'll do a final check for fit. I've used a couple of washers to temporarily pack the flange away from the head so I can see that the pipe is protruding all the way through the flange. I've achieved a reasonable fit and angle on this pipe and have clearance between the pipes and the mocked up chassis tube. It's now ready for final welding, but before I do that I need to fit these threaded bosses for the oxygen lambda sensor. I think this is where my step drill steps in. A bit of detail work to achieve a good fit pipe to flange, and it's time to weld her up. I tidy up inside the mouth of the pipe with various devices, then clean up to the face of the flange on the linisher, and the pipe for number 7 cylinder is finished. The pipe for number 1 cylinder was more straightforward, but was just a repeat of the process. Because the process is repeated, I can just jump to showing the finished item fitted up to the dummy engine. Then it was the turn of the centre 2 pipes. They are tackled in the same way, but the close proximity of the two pipes requires some thought to ensure you can get to all the places requiring welding. The two centre pipes are assembled and tacked together in this shot, just the welding to be completed. Moving on to the driver's side, the process is the same. This side is a bit easier, but there are still some tight gaps to address. As always, each pipe must be thoroughly cleaned inside and out before welding. Both exhaust headers are now complete, and I can say with confidence that this fabrication has been easier and considerably faster using pipes preformed by DEA Performance. That's better. Who said I was exhausted?